Okay, so next we're gonna be looking at the HTTP, the Hypertext Transfer Protocol. It was developed together with HTML, the Hypertext Markup Language, by Tim Berners-Lee at CERN. And he wanted to design a system that makes it possible to exchange documents across researchers and interlink those documents. So if you think about it, that's not at all what we're using the HTTP nowadays. HTTP is the main protocol used for web. Usually we consider everything a web application when it's delivered over HTTP. But in the end, nowadays, we don't exchange static documents to interlink them. Usually the web nowadays is very dynamic. Everybody who visits a specific website gets different content returned. So this is an example of what in the software industry is usually called legacy code. Yeah, that's code that was written a long time ago and somewhat serves a different purpose now, but it works somehow. Yeah, we have the same thing here in protocols. A lot of the protocols we're using nowadays were designed in the 90s or sometimes even earlier, and they still get the work done, but they're doing a very different job now than what they were designed to do back then. And we'll see that this leads to security vulnerabilities. When we look at the classical OZ layer model, HTTP is in the application layer, usually based on TCP in the transport layer and IP in the network layer. This is usually what we refer to as the web, HTTP over TCP over IP. So the HTTP, the Hypertext Transfer Protocol, is a fairly simple text-based protocol. It is stateless. What that means we will see when we look at sessions, because that has big security implications. Essentially, stateless means the web server never knows who you are when you issue a request, even if you have issued a request before. So every interaction starts with a request. The request starts with the request line that looks something like this. It starts with the HTTP method you want to use, in this case get, which means return the content I want to see. Then we get a path on the web server, and then we get the HTTP version. After this request line, we get headers, which are key value pairs. In this case, this is from a response key header pair. This is content type, a text HTML, so the browser knows that what is being returned is HTML. So the browser knows how to interpret it. Afterwards, there comes an empty line and then the actual body in the response that can be, for example, HTML. So we're gonna look at some example requests. I'm using curl here. Curl is a command line utility that you can use to issue HTTP requests. So first, we have the request line, which is get, then the path on the web server, question mark. Afterwards, there come key value pairs. These are the request parameters, and then the HTTP version. Then comes a new line, and HTTP uses Windows style new lines. That is \r\n. You probably know that if you have programmed Windows applications before. 2-byte new line. Then there come the headers. Here host, so the web server knows which host we want to talk to. A user agent is usually provided, and then accept means what content types we accept, as an answer, and here's a wildcard. We accept everything. Then comes an empty line, so the server knows that the request has ended, and it can send the response. So this is what's sent over TCP. This is what's being received over the same TCP socket. The server responds HTTP 200 OK, means the request can be served. We get a content type, so the client knows, the browser knows how to interpret the answer. We get a content length, which is important, obviously, and then server date, which is a mandatory header. And sometimes we get stuff like the web server being used with a version. From a security perspective, this might leak information, obviously. If we look for a certain type of vulnerability that's only present in a specific version, we can see the version here. But it doesn't really matter, because usually if we have a specific vulnerability, we can just test it against as much web servers as possible. And then comes an empty line, and then the actual document that's being displayed in the browser. If you're interested in what kind of headers are around, there's a list of all specified headers here. But some web applications use other headers that are not specified in this HTTP standard. These are usually prefixed with an X. For example, X forwarded 4 is sometimes used in web applications on the reverse proxy side. The leading X means that it's not part of the HTTP standard. It's just used by this particular web application. Okay. With curl, we can also issue a post request. That's another type of request I want to show you. With a post request, we usually transmit data from the client to the web server. In this case, we transfer the parameters username and passwd. And with curl, you can do that with the ---- data option. And post works very similar to get. We have here the post, then the path, and in the HTTP version, we have some headers. The difference between post and get is that in a post request, the data is transmitted in the body, the parameters. In the get request, they were transferred in the URL line. Here, they're transferred in the body of the request. Okay, these are the most common request types. Typical web flow of a web application is we have the end user that uses a browser. The browser issues a request, for example, GET request, that it gets transmitted via TCP IP to a web server. The web server has a backend that gets the request and then somehow builds an answer document dynamically based on the input and gives that dynamic document that has been built back to the web server. The web server delivers it via TCP IP to the browser, and then the browser displays it. This backend that is being used is usually some sort of dynamic programming language. This could be PHP, for example. It can also be Python or Perl or Ruby or Node.js or Java. Doesn't matter. Very often, this backend also communicates with a database of some sort. Yeah. So usually web applications consist of the programming language for the backend and database sometimes. The database could be anything from rational database to NoSQL or whatever storage you can imagine, Redis, key value stores. Yeah. So when we talk about web applications, this is usually the workflow. Browser to web server to backend, communicating with the database and returning the answer. And that was it about PHP. This was the presentation about HTTP.